What up, calculus? You ready for an AMI, David? I'm sure you are, because I'm certainly ready. Got it all broken out and everything. I even wrote the equation before we got there. So, just as promised, we're going to go through a little bit more of the notes today. I'm more specifically looking at the 5.2, example 6, letter C. So the sine squared of x minus cosine of x, the one we kind of decided not to do today. But we're doing it today, yeah. So we're trying to find the absolute extrema of the function on the given interval. So right now we have a closed interval between 0 to 3 pi over 2. It's continuous all throughout that. No breaks in sine or cosine. So we know we can apply the extreme value theorem. So BJ chilling there. So your critical values or your critical points are going to be your endpoints. So 0 to 3 pi over 2 automatically. So we'll put 0 there. That way we don't forget. And then whenever your derivative is equal to 0. So we also have to find h prime. So using h prime, let's start off with that. So h prime of x is equal to, well, sine squared's derivative is, it's a chain rule. So you got to do power rule on the square. So 2 sine of x, so go down a power, the sine of the first, times the derivative of your inside function, meaning the derivative of sine, which is cosine, minus, and then derivative of cosine is negative sine, so minus negative sine of x. Cool. So now rewriting and setting it equal to 0, so h prime equal to 0, so 0 equals 2 sine of x cosine x plus, because minus negative, sine of x. So now, how do we solve this? Well, if you remember all the way back from trig, I know it's toward the end, but solving these equations, you don't just divide by sine. You want to actually factor sine out. So factoring out sine, we got sine of x. And then, well, now you got the 2 cosine of x plus 1. So now we got 2 scenarios. It's either when sine of x equals 0, so, or whenever 2 cosine of x plus 1 equals 0. So dealing with that sine of x equals 0 first, just remember on the unit circle, sine's your y. So it's going to be 0 at x equals 0. Then also x equals pi. And typically we do x equals 2 pi as well, just for good measure. But because between 0 to 3 pi over 2, 2 pi is a little bit more than 3 pi over 2. So we'll omit that for now. And then we also got to figure out when 2 cosine of x plus 1 equals 0. So 2 cosine of x equals negative 1. And then divide by 2. So you got cosine of x equals negative 1/2. So now unit circle time, when does cosine equal negative half at? So x equals, well, unit circle, cosine's your x. It's going to be negative at quadrant 2 and 3. So x is equal to, oh boy, 2 pi over 3. So yeah. And then x is also equal to negative a half at 4 pi over 3. So the one in quadrant 3. So now those are your critical values. You got 0 pi, 2 pi over 3, 4 pi over 3, then 0 to 3 pi over 2. So 0 is already a critical value. So now those are going to be your critical values. Now, question 1 on your Google form that you're going to fill out for me is, what's your favorite function? Just like graphing wise, whether it be for the memes or whatever, or your least favorite, right? So in my opinion, it's my personal, one of my least favorite functions of all time, I'm just going to write it up here. I probably have already talked about this extensively. Sine of 1 over x. Now, if you're ready for a trip, put this in Desmos or GeoGebra and you'll understand why that's one of my bottom tier D tier functions. Kind of looks cool, but also at the same time, it just has a terrible properties. It's not really that useful either. It's just for the memes. Yeah, that's question 1 for you. Okay, back to the calculus part. So now we plug these values in. So if you plug into the original, not the derivative, but the original, sine squared minus cosine. You plug in 0, sine squared of 0 is 0 still, minus cosine, and cosine of 0 is 1. So you're left with a -1. Okay, moving on to the next critical value, going in order from least to greatest, hit up 2 pi over 3. So you plug in 2 pi over 3. Sine of 2 pi over 3 has got to be I think it's 3/2 if I'm not mistaken. So root 3 over 2. So positive root 3 over 2. Square that. You got 3/4 minus, and then cosine of 2 pi over 3 is going to be -1/2. So you got 3/4 plus 1/2. So that should give you 5/4, which, yeah, 1.25, yes. Okay, so positive 5/4. So plugging in pi. Sine of pi is 0, so sine squared of pi is still 0. And then minus cosine of pi is -1, so minus -1 is +1. So now you got good old pi, 1. Next up on our chopping block, we got 4 pi over 3. So let's plug that in. It's very similar. You plug in 4 pi over 3 for sine, you get root 3 over 2. Square it, you get 3/4. 3/4 minus, and then cosine of 4 pi over 3 is actually -1/2 because we already found that earlier. So it's going to be 3/4 plus 1/2 again. So the exact same thing as that. And then finally, let's check our endpoint, 3 pi over 2. 3 pi over 2, plugging that in. Sine of 3 pi over 2 is -1. Square, you got +1 now. Minus cosine of 0. So 1 minus 0 is 1. So there we go. So now we need to look for our absolute max and our absolute min. I don't think it's a shocker. Like, correct me if I'm wrong. Your absolute min is at x equals 0 because you got a negative value. And we already know f of 0, or h of 0, my bad, is -1. So that's your absolute min. That's the absolute minimum it can go. Absolute max. In fact, we actually got 2 of them. So our absolute max is 5/4, and that's going to occur at x equals 2 pi 3, 5 over 3, and x equals 4 pi over 3. And of course, it's going to be 2 pi over 3, and give you the 5/4, and similar with the 4 pi over 3. So dot. Now, I'll post the keys to 5.1 and also the chain rule review. That way you can kind of look through it and catch up if you need to. I won't post 5.2 quite yet, but I'll get in the habit of doing it more often for the answer keys. You guys have been actually slaying this semester, so I'm very, very impressed and proud. When we get back from AMI, I do want to go through the, because a lot of you guys had questions about the local min versus absolute min and local max. It's going to make a lot more sense once we get to that first derivative test. And if you want to, you can just look ahead a little bit at the notes, 5.3. As you can tell, she goes through the vocab pretty heavily, but usually I'm able to kind of break it down and kind of dumb it down a little bit for even myself, because sometimes she goes way too hard on it. But your second question on the Google form that I want you to fill out is, I want you to research a little bit about derivative applications for your future career that you want to go into. So, I mean, part of the reason why a lot of your majors require calculus, or your intended majors, is because, I mean, there's probably a reason for it. So I want you to research of a derivative application that's going to go into your field of research or your field of study. So, for example, if you're going into like business or econ, look up a derivative or application of derivatives for businesses. There's quite a bit of them, and actually we're going to go back at in Unit 4 and look at a lot of different applications. you're going into medical, though there's plenty of applications. Engineering, obviously. Physics is a really cool one too. So that's going to be your second question for your Google form. So question 1 is going to be favorite or least favorite function, and question 2 is going to be the application. So stay warm, email me with any questions, and I will see you when we get back. Bye.